Six. So today we'll be taking one question from quadrilaterals where a rhombus ABCD is given to you, right? Let's say this is the rhombus and these are the vertices A, B, C and D, right? Let's say this is the rhombus. This is a rhombus. So whenever the name rhombus is coming into your mind, I hope you remember a rhombus is having a property that all of its four sides are equal and the diagonals of a rhombus intersect each other at 90 degree, and area of the rhombus is half into d1 into dt, that is half into diagonal 1 into diagonal 2 is the area of the rhombus, right? And another property is that the diagonals intersect each other at 90 degree, right? So that's it. So these are the few of the property of the rhombus which you recall. So here in this question, ABCD is a rhombus and AB is produced to E. So you need to extend this line till a point, let's say here, and this point is E, right? And this is also extended into the another direction, that is to E in left and F here, okay, F, right? Then we need to prove that ED and FC are perpendicular to each other, and the condition is that AE equal to AB equal to BF. That means AE is this length is equal to AB, this length is equal to BF. So AE is equal to AB is equal to BF. This is given to you. I mean to say that this AB when extended to E and F, then three line segments will be formed. You can see this entire line segment E to F is considered of combination of EA plus AB plus BF, right? And into the question it's written that EA or AE, that means this length, this one, is equal to AB, that means this AB side of the rhombus, and equal to BF, this one, right? Now we need to prove that ED and FC are perpendicular to each other. So basically ED is this line, right? ED is this line and FC is this line, right? How they are perpendicular to each other? That means you need to extend it, and you need to extend this FC also. So whenever they will meet, this angle should be 90 degree. This we need to prove. This is 90 degree, this we need to prove. How this is 90 degree, right? Now let us do one thing, students. Let us do one thing. You know that you recall the property of a rhombus. So we can say that AB, and condition given is that A equal to AB equal to BF. So if you are considering A to F, then AB is equal to BF, right? And since AB is the side of a rhombus, then BC is also the side of the rhombus. Then AB can be said as equal to BC. This one, isn't it? So in triangle BFC, this triangle, in triangle BFC, this side and this side are equal. That means this angle should be equal to this angle. Why? These are the angles opposite to the equal sides, right? And in this triangle we can say BC equal to BF. Therefore the angle opposite to BC is angle F, that is angle BFC, and angle opposite to BF is angle C, that angle BCF, and both of these angles are equal. So rather than writing those numbers, just writing the angles, just write the numbers, angles in numbers. Let's say this is angle 1, this is angle 2, right? Then we can say that angle 1 equal to angle 2. Angle 1 is equal to angle 2. Why? Because BF equal to BC. Since BF equal to BC, right? And what we have used? We have used equal angles subtended by equal sides of a triangle, right? So this property is used. Equal angles are subtended by equal sides of a triangle. So therefore angle 1 equal to angle 2. And students, if this angle be this one, let's say if this is angle 3, if this is angle 3, and you know that any exterior angle is equal to the sum of interior opposite angles, so we can say that angle 3 is equal to angle 1 plus angle 2. So I'm not writing the theorem over here, I am writing directly. And angle 3 is equal to angle 1 plus angle 2, because exterior angle, any exterior angle is equal to the sum of interior opposite angles, right? Now here angle 1 is also equal to angle 2, you have written, right? So rather than putting angle 1 and angle 2, angle 1 plus angle 2, you can write angle, in place of angle 1 write angle 2. So we can write angle 2 plus angle 2. So we can replace in place of angle 1 as angle 2. Then we are left with angle 3, which is equal to 2 times angle 2, right? Angle 3 is equal to 2 times angle 2, right? Here angle 3 is equal to 2 times angle 2. Now similarly you can consider this triangle. That is triangle, which one? AED. So in triangle AED, which is this triangle, in this triangle, in triangle AED, in triangle AED, as we proved into triangle BFC over here, similarly in triangle AED, this blue shaded triangle, we can see AB is equal to AE. This is given to you, right? Since AB equal to AE, then we can say that AE, AB equal to AE and AB is equal to AD also, right? These are equal. AB is equal to AD also, because these are the sides of a rhombus. All the sides of a rhombus are equal, okay? So AB is equal to AD. Since AB is equal to AD and AB is also equal to AE, so we can write AD and AE are equal, right? So if AD and AE are equal, I'm writing, since AE equal to AD, right? Then this angle, should be equal to this angle, because these are the both these angles are formed by the both sides which we have spoken, that is AE is forming this angle. Let's say this is angle 4. Let's say this is angle 4, right? And let's say this is angle 5, right? And this angle which is forming in external to this is angle 6, right? Now since AE equal to AD, we can say that angle 4 is equal to angle 5, isn't it? Because these are the angles opposite to the equal sides AE and AD, right? Therefore angle 4 equal to angle 5. Since angle 4 equal to angle 5, we can write angle 6 as equal to angle 4 plus angle 5. How? Because this is the exterior angle which is the sum of interior opposite angles, right? This is the triangle AED, and if this is extended over here towards B, then this angle 6 is formed, and this is the exterior angle, and this is the sum of interior opposite angles 4 and 5. So we can write that angle 6, we can write angle 6, let me write it. Angle 6 equal to angle 4 plus angle 5, right? Angle 6 equal to angle 4 plus angle 5, right? And just if this point is not known, you can just name it. Let's say this is O, the vertex where the 90 degree need to be proved. This is O. And since angle 6 equal to angle 4 plus 5, that is sum of interior opposite angles, and this is the exterior angle, both are equal. So angle 6 equal to angle 4 plus angle 5. Then in place of angle 4, we can write it angle 5. So we can write angle 5 in place of angle 4 here. You can see it's very easy. Plus angle 5. So angle 6 can be written as 2 times angle 5, right? Angle 6 can be written as 2 times angle 5. So this relation is derived. Now here we have proved angle 3 equal to 2 times angle 2. Let's say this is equation 1, right? And we have also proved angle 6 equal to 2 times angle 5. This is relation 2. So from relation 1 and relation 2, what we can write that since angle 6 is equal to 2 times angle 5, right? And angle 3 equal to 2 times angle 2, right? And also you can see AD and BC are parallel lines because it's a rhombus, right? It's a rhombus AB, then we can say that AB and BC are parallel lines, right? So I'm writing since AB is parallel to BC, because the rhombus is also a parallelogram, right? And you can see this is the transversal AB. If these are the parallel lines, then this AB is the transversal to this parallel line, right? Then we can say that angle 3 plus angle 6 equal to 180 degree. We can write if AB parallel to BC, then AB is the transversal, and angle 3 plus 6, that is the sum of interior opposite angles formed due to the transversal. Then angle 3 plus angle 6 will be equal to 180 degree, isn't it? This is angle 3 this is angle 6. Both of these will add up to form 180 degree. This I'm writing angle 6 plus angle 3 is equal to 180 degree, right? And angle 3 is 2 times angle 2. So just using equation 1 and 2, we can write, in place of angle 3, we can write 2 times angle 2, and in place of equation angle 6, we can write 2 times angle 5 using the equation number 2, 2 times angle 5, and both of these will add up to 180 degree, right? So here we can write, if 2 is taken common from both, here if this 2 is taken common from both the terms, these 2 can be brought into the denominator of RHS. Then angle 2 plus angle 5 can be written as 180 divided by 2, which is equal to 90 degree, right? So we can write angle 2 plus angle 5 is equal to 180 degree by 2, which is equal to 90 degree. That means the sum of this angle 2 and angle 5 is proved as 90 degree. Angle 2 plus angle 5 is 90 degree. Here you can see, right? So this 90 degree which you have proved, this will help you to solve your question almost 100%. Let us see how. Since angle 2 plus 5 is 90 degree, and this is the triangle which is formed, triangle EOF. So sum of all the angles, let's say this angle is angle number 7. This is angle number 7, that is angle COD, right? Then we can write 2 in triangle EOF. Angle 5 plus angle 7 plus angle 2 is equal to 180 degree, because this is angle 7, this is angle 7, right? Sum of these three angles is 180 degree, and 2 plus 5 is already calculated as 90 degree. Here you can see this one. So since 2 plus 5 is 90 degree and sum of all the angles of any triangle is 180 degree, then in triangle EOF, if this 90 degree will be reduced, then the value of this angle is formed, that is angle 7, and that will be equal to 180 minus 90, which is equal to 90 degree. That means this ED extended to O and FC extended to O, these two lines are perpendicular to each other, and in this way we have proved it, right? So since 2 plus 5 is 90 degree, then we can write in triangle EOF, in triangle EOF, angle 2 plus angle 5 plus angle 7 equal to 180 degree, right? Sum of the all angles of any triangle. And what is that triangle over here? That is triangle EOF. That is triangle EOF. So here we can see angle 5 plus angle 7 plus angle 2. So all these three angles I have written over here. Angle 2, here you can see angle 2 plus angle 2 plus angle 5 plus angle 7, but 2 plus 5 is 90 degree. So let's say this is equation number 3. So using this relation, in place of 2 plus 5, what we can write by using equation number 3, this as 90 degree, right? Then 90 degree plus angle 7 will be equal to 180 degree, which will give you the value of angle 7 equal to 180 degree minus 90 degree, which is coming as 90 degree. So here students, you can see angle 7 is proved as 90 degree, right? Since angle 7 is 90 degree, that means if this angle 7 is 90 degree, that means ED and FC, because ED is extended to O and FC is extended to O, then we had proved ED is perpendicular to FC, right? So in this way we have proved that ED is perpendicular to FC. This ED is perpendicular to FC, right? So student, in this way we have solved this question, right? If you find it useful, you can just like and subscribe. Thank you so much for watching and keep on learning. Bye bye, take care.